For the next couple of lessons, we're going to talk about this thing called factored form. And factored form is, in a sense, reducing a polynomial. I guess that would probably be the most logical connection. Like when we reduce a fraction, this is reducing a polynomial, in a sense. A polynomial is in factored form when it's written as a product of its factors. So we talked about standard form in an earlier lesson. This is standard form right here, where it's in decreasing order of exponents, right? This is the largest exponent, then this is the next largest exponent, and this has no exponents. This is that same polynomial, but it's written in factored form, like they've done the reverse distributive property. If you think about distributing this polynomial, x times x would give you x squared, and x times 2 would give you 2x. And so these are the same things, but this is written in factored form. So this, in a sense, would be like the reduced version of the original polynomial. We can turn polynomials into equations when we can later, as we get more advanced in our polynomials, we're going to be using them to solve realistic situations. And when one side of an equation is a polynomial in factored form, and the other side is 0, you're going to use this thing called the zero product property. The zero product property is actually something that's more logical than it might sound. It's something that you've dealt with all the time. And the solutions of a polynomial equation are also called roots. So sometimes the question might say find the roots of an equation, and that's looking for the values of x as well, the solution. So here's what the zero product property is all about. And like I said, it's something that you've actually experienced already. If I give you this equation, let's say 5 times x equals 0, what is x? There's only one value of x. What is it? Well, in order for this to be equal to 0, x has to be equal to 0. Right? Because the only way to get a 0 answer is if one of these is 0, and since it's not 5, then it has to be x. So the zero product property says that if you're multiplying two things and you have a 0 as your answer, then either one or both of the numbers have to be 0. So if the x wasn't 0, that meant that this would have to be the 0. And here's exactly where it says it in algebra. If a times b equals 0, then either a is 0 or b is 0. So one of these two pieces has to be equal to 0. And you say, big deal, but that's really the root of the idea behind the zero product property. So we go down to example 1, and they want us to solve the equation. Well, I'm going to do this, I'm going to split it right down. You see how there's two factors here, and the two factors are x and x plus 8. So I'm going to split it right down, the two factors, and I'm going to say either x equals 0 or x plus 8 equals 0. So again, what I've said is that in order for these two pieces, these two parts, to be multiplied together and equal 0, either this is true or this is true. So if the left side of the line is true, then x is 0, right? Duh. If the right side of the line is true, then x would be negative 8. Now again, we don't know which one it is, so we're going to say x is 0 or x is negative 8, but one of those numbers has to be the value of x in order for it to be true. Okay, if you're up for it, try letter B on your own. If not, that's okay. Follow along with me. They've written the two factors, x plus 6 and x minus 5, so I'm going to split it right down those two factors. And I'm going to say, well, in order for them to multiply and become 0, either this part is the 0 or this part is the 0. I don't know which one it is, but one of them has to be 0. So if the left side is true, that means that x equals negative 6. Or the other side could be true. x would be 5. So either x is negative 6 or x is 5. I'm not sure, but one of those values is the x. And so that we're not getting an exact answer for x. We're saying it's either this or it's this. If you're up for it, try example 2 on your own. But what we're going to do is we're going to split our polynomial down the roots, and you can tell that they're roots by the fact that they're in parentheses. So the first part is going to say 2a plus 7 equals 0. So that's one possibility. And the other possibility is that 2a minus 7 equals 0. Now I can't solve this in my head like I did the other one, so I'll do some inverse. So minus 7. And I get 2a equals negative 7. So divide by 2. A equals negative 7 halves. Now when you go to the choice, you can see it has to be A, because that's the only one that includes negative 7 halves. But let's just show that we can get the other answer from the other root. So I'll add 7 to both sides here. And I get 2a equals 7. And when I divide by 2, I get positive 7 halves as the other root. And when you're ready, let's go to the next example. The arch of a fireplace can be modeled by this polynomial right here, where x and y are measured in inches. The x-axis represents the floor. Find the width of the arch at the floor level. So we're finding the distance from here to here, because that's one ending of the fireplace and this is the other ending of the fireplace. So we're looking for this distance. And if we can find the roots, then we know what the values are, because at the floor level, the y value is 0, because if you think about this being on a coordinate plane, these are going to be the x-intercepts, and we know at x-intercepts, that's where the y value is 0. So if I take my polynomial up here, and I plug in 0 for y, then I can solve and get the x values. So 0 equals negative 1/9 times x plus 18 times x minus 18. So now you split it down the roots, and there are 3 different parts to it, because there are 3 things being multiplied. But you can't solve a piece that doesn't have a variable. So if you go to, like, you can't set negative 1/9 equal to 0, because negative 1/9 can't be equal to 0. So this piece right here can't be solved, because it's just a constant, it's just a number. So I'm going to leave that portion alone. But I'm going to solve the 2 pieces that have variables like I did in the other example. So one of these is x plus 18 equals 0. The other is x minus 18 equals 0. So that gives me one value being at negative 18 and the other value being at positive 18. So obviously this is the positive 18 and this is the negative 18. So now you have to go back and read the question. Find the width of the arch. So the width of the arch goes from negative 18 to positive 18. So that's 36 inches. So make sure you go and actually answer the question. If you have any questions, write them down and ask me when you come to class.